Around the time that Walter Fleming was studying the cell division process, biologists already knew that fertilization resulted from the union of two sex cells, sperm and egg. What they didn't know was why these were the only types of cells in the body capable of reproducing new life. What made them different? The first answer was provided in 1883 by Belgian zoologist Edward van Beneden. Van Beneden was studying a species of roundworm when he discovered that nearly all of its cells contained 4 chromosomes. The only exceptions were the roundworm's sex cells, the male sperm and the female egg. These cells had only 2 chromosomes. Van Beneden observed that once 2 of the sex cells came together, a full set of 4 chromosomes appeared in the fertilized egg. But just why the sex cells had only half the number of chromosomes compared to all the other cells was still a mystery. Then in 1887, German biologist August Weismann entered the picture.
He knew about the work of Van Beneden, who had shown that the sperm and the egg bring in equal numbers of chromosomes. But Van Beneden's work had not really worked out the details of how the chromosomes were reduced in number.
He saw them go in half, and he saw them recombine.
He saw that the sperm and the egg brought in half the number of chromosomes as the body cell, but he didn't really know how they got rid of the half that they got rid of. So Weismann discussed how this might happen from a theoretical standpoint. And he said, well, what you could have would be that either every one of the chromosomes would just split in half, and half would go off one way and half would go another way, or you could have it more complicated, that the chromosomes could pair, and then instead of splitting, they just separate again.
After years of studying the behavior of chromosomes, Weismann determined that at some point a developing organism signals its sex cells to divide their number of chromosomes in half. Weismann called this very special form of cell division meiosis.
I think they will look back and see this as the golden age of biology, because, let's say, 200 years between 1800 and 2000, we went from not knowing what distinguished a stone from a frog. Mm-hmm. Okay? And now we know the difference between a stone and a frog.
That's pretty good.
Yeah. So that, in a real sense, we've answered the old philosophical question of what is life. Maybe not to everybody's satisfaction, but we're well on the way.